So we're going to begin our talk here, moving forward with alternating series and then conditional convergence, which is a type of convergence that generally applies to some alternating series. So alternating series are series when the terms that you're summing, you end up with plus, minus, and that sign is changing. And that generally occurs when you have -1 to the n or -1 to the n plus 1, or the other way you might see it written would be -1 to the n minus 1. Okay, so basically we have a -1 raised to a power, and a -1, if it's raised to an even power, is going to turn positive. A -1 raised to an odd power would remain negative. So as we count through our indices, 1, 2, 3, etc., we'll end up with positive, negative. So let's look at a couple of basic series. So this first, here's an example of an alternating series. We've got the sum from n equals 1 to infinity of -1 to the n times 4 over 2 to the n. And if we start to list the terms in this series, we would get -2 minus 2 plus 1 minus 1/2 plus 1/4 minus 1/8, all the way down to where we're adding some nth term, which is going to look like -1 to the n times 4 over 2 to the n. And of course we can continue this. All right, so this represents a geometric alternating series. And in this example, this series has a constant ratio of -1/2. And you know the absolute value of the ratio for any geometric series is less than 1, it would be convergent. In this case, we would be able to find this converges to -4/3. Okay, so this is a convergent alternating geometric series. All right, let's see. Another alternating series, and we're going to do an example with this one here in a second. We've got the sum n equals 1 to infinity, -1 to the n plus 1 over n. And so this looks a lot like our harmonic series, but this is an alternating harmonic series. And keep in mind, you know, we talked about a harmonic series before. That was the sum of 1 over n. So this is just got that alternating term added in there, and we would be summing that. So if we look at what these terms do, we have 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 plus, and then we would be adding some -1 to the n plus 1 of that 1 over n. And again, those terms can continue. So what we want to remember is that the harmonic series, the regular harmonic series, is divergent. But the alternating harmonic series converges. So the regular is divergent, but this guy, the alternating with that -1, this series converges, and it converges to the natural log of 2. All right, and like I said, we will examine that shortly. But the regular harmonic series, which we talked about a few videos back, is a divergent series. And this is where we'll get into also some of our conditional convergence. So not all alternating series do converge. Some of them diverge. So we have a sum here. n equals 1 to infinity, n times -1 to the n plus 1. And this would just equal 1 minus 2 plus 3 minus 4 plus 5 minus 6, continuing on. And this is just a general alternating series, but this guy is divergent, all right? So this is divergent because the nth term, coming off this way, some n value, the nth term does not approach 0. And if you look at the two terms or series above, as the indice increased as we moved down the line here, the terms became smaller. 1/5 is much smaller than 1. Or on our second one here, we have the terms are actually getting bigger. So this is not convergent. The two above were both convergent series. And we're going to talk about absolute convergence in a minute. The top one is absolutely convergent. The middle one is conditionally convergent. And then this bottom series is divergent. So, you're hearing these two types of convergence. I'm talking about absolute convergence, and then I'm mentioning this conditional convergence, which we haven't talked about, and we're going to get to that after we've examined alternating series a bit more. So if something is absolutely convergent, that means we look at the convergence of a series taking the absolute value, the positive of all of those terms, then we know we can say that this is a convergent series. But conditional convergence, this new type of convergence, does not imply the same.